Earlier we had seen that a current-carrying wire produces a magnetic field. And we also saw the pattern of the magnetic field around a bar magnet. Now I want you to think about what I'm asking you next. If we take any current-carrying conductor instead of a bar magnet, then what determines the pattern of magnetic field due to that conductor? Does the pattern depend on the shape of a conductor? Let us see with the help of an experiment. Consider the figure shown here. A copper wire passes vertically through a cardboard. Now sprinkle iron filings on the cardboard and plug in the key. When the current starts to flow in the wire, the iron filings which were randomly arranged earlier align themselves in concentric circles around the wire. These concentric circles represent the magnetic field lines of a current-carrying wire. In our experiment, if we want to find the direction of magnetic field at a point, just place the magnetic compass at that point. How does this give us the direction? The direction of the north pole of the compass gives the direction of the field at that point. Now what if we reverse the direction of current and repeat the same experiment? We see that at the same point, the north pole of the compass needle points exactly opposite to its initial position. Also, if we vary the current in the wire, which means if we increase or decrease the current in the wire, then the deflection of the compass needle also varies accordingly. Hence, we can say that the strength of the magnetic field also changes with the current passing through the wire. Now, does this mean that we need to conduct the experiment every time we want to find the direction of the magnetic field? Not really. Let us look at a convenient way to find the direction of magnetic field. Imagine that you are holding your right hand around a current-carrying conductor and your thumb points in the direction of current. The direction in which our finger curls gives us the direction of the magnetic field lines. This is known as the right-hand thumb rule. So for a straight current-carrying wire, the magnetic field lines are concentric circles, and if the wire carries current in an upward direction, then the magnetic field lines are in an anti-clockwise direction. And if the current is in the downward direction, then the field lines are in a clockwise direction. Remember, in both cases, you're using your right hand. But what if I bend this wire in the form of a circular loop? When we pass current through it, what will be the pattern of the magnetic field? Move on to our next video to find out more.